So we're going to say here that Jeremy is training for a bike race by biking to his friend's house. Jeremy biked 144 kilometers to Sam's house. That's intense. And then Jeremy biked 144 kilometers back to his own house. Friend lives in Strathmore. Okay. He biked twice as fast on his way to Sam's house. He biked twice as fast on his way to Sam's house because he had energy. And then twice as fast on his way to Sam's house. So he biked twice the speed, as fast the time. His total time is 27 hours. Okay, not the best sentence structure, but we'll deal with it. So what rate did Jeremy bike in both directions? That will not, that's true, but not true. Okay. So we're making ourselves a chart. A chart will always have, here we could say bike 2. It's on the back half if you want, right? Bike 2 Jeremy's, bike home. Whatever you want to label it. And then we have distance. Speed. Or in this case, we could call it a rate. It's the same thing, different pile. And then time. Now, you can use the DST triangle. It drives a bunch of people crazy. I don't really care. This is not the part that I care about. You just go in alphabetical order. If you want the distance, you cover up the distance, and it's speed times time. If you want speed, you cover up the speed, it's distance divided by time. If you want time, you cover up the t, and it's distance divided by speed. So you can just use the triangle, because that's not what I'm testing you on. I'm testing you on rationals. All right, so let's fill in what we do know. Just so you know, when we do these tables, you will always have 2 knowns in both lines, and then the other box that's empty, we'll use this formula to fill. Okay? Your question, or your equation, sorry, should look like a rational expression, which means have a variable in the denominator. Why? Because you're in the rationals unit. It would be really silly if I gave you a word problem that didn't fit in this unit. So if you're making something that doesn't look like a rational, question yourself. Okay? So let's fill in what we do know. We know that the distance both ways is 144. And what we can do here is we can write kilometers, because we know that that is what the distance unit is in. We know his total time is 27. Total time is going to be down here. 27, and it's hours. Now, he biked twice as fast on his way to Sam's house. So that would be 2 times the speed of biking home, correct? So what could we label biking home as? X. And then biking to Jeremy's would be 2x. Now we'd have to do a let statement. So we'll say let x represent the speed bike to Jeremy's friends. I should have a friend here, sorry. Bike Jeremy's friends. Jeremy's friend. Sure. Let x represent the speed. Jeremy rode on the way home.
Oh, training, that's really slow.
All right. So we have 2 boxes empty, which I told you that we'll always have 2 boxes empty. How do we fill those 2 boxes? A lot of people will sit and stare and just not finish the question. That is not how we fill the 2 boxes. We don't sit and stare. We say, Mrs. Lepp told us how to fill the 2 boxes. We fill them with the formula, correct? With the triangle formula. So what is empty right now? Time, correct? So if I cover up the time part of this, what is it going to be? Distance over speed. I have distance and I have speed, right? So the time here would be 144 over 2x. And what's this one going to be? 144 over x. Do you see that? Does that make sense? So the two missing spots will always be filled in using the formula. Now we have to be able to come up with a formula from this word problem. If I take the time to Jeremy's, the time from back to home, time from Jeremy's to his friends, then from Jeremy's friends to home, I'm going to get 27 total hours, correct? So how could I set up the equation? 144 over 2x, and then what do? 144 over x, and what am I going to do with those two times? The total time is 27. What am I going to do with them? Add. Now solve it. Go. What are we going to have to do? Common denominator is what? 2 and x, correct? So you have to multiply the first one by nothing, the second one by 2, and the third one by 2x. Try it out. So we're going to multiply this one by nothing, this one by 2, and this one by 2x. So I get 144 over 2x plus 288 over 2x equals 54x over 2x. This is a nice equation, isn't it? Because there's no squares. We agree? We can put this side together. What's 144 plus 288? 420 what? 32? Okay. I was like 20, huh? Okay. And then we get 54x over 2x. Now, before we drop off to 2x, we say x can equal 0, which makes complete sense. Because x is the speed he drove on the way home, which is 0. He literally would go nowhere. He's just standing on his bike. He's just sad. That's what he is. That's what would be me, being like, I have to go 140 per kilometer. I wouldn't have made it there, let's be completely honest. All right. So we have 432 equals 54x. Divide by 54, and what do we get? I do not need to cross that up here. X equals 8. 8 what? Kilometers per hour. Because where is x found in this box? Here, and this is the speed. If this is kilometers, this is hours, this is kilometers per hour. So we literally just found the speed of him on the way home, correct? 8 kilometers per hour. Now, it says here, what rate did Jeremy bike in both directions? So on the way home, 8 kilometers on the way home. How do we find out how fast on the way to his friends? You just take it and times by 2, right? Because it's this one. 2 times 8 kilometers per hour, which is, I guess it's not x. 2 times 8 kilometers per hour, which is 16 kilometers per hour on the way home. Or way to Jeremy, sorry. Jeremy's friend. Okay, then we're going to flip, well, you're going to not flip over because you're on the back side. We're going to look at number 3. So this was your number 2. Here's number 3. So here says, John's family travels 300 kilometers from their home to a family reunion. His cousin Susan and her family take the same amount of time to travel 200 kilometers from their home. John's family is over the speed limit. That is what's happening. Or else, Susan is very under. Yeah? Determine the speed of both vehicles given that one of the vehicles travels 30 kilometers faster than the other. I can guess which vehicle is driving faster. Which one do you think is driving faster? The 300 kilometer. John. Okay, so let's set up our little chart. So we have John. We have Susan. You have distance, speed, time. So John's family travels 300 kilometers. And Susan's family travels 200 kilometers in the same time. So that's important. All right. These times equal, correct? If they're the same time, their times are going to equal. Then it says that one of the vehicles travels 30 kilometers per hour faster. So which one is X and which one is 30 kilometers faster? Which one's the slower one? Susan. So Susan is going to be X. So let X represent Susan's speed. Susan's family's speed, I guess. Now the last one said 2 times faster, so I went 2x, correct? This one says 30 kilometers per hour faster, so what am I going to do? Yeah, x plus 30, right? So if it's times faster, you multiply. If it's just kilometers per hour faster, we're going to go x plus 30. Wait, I have 2 boxes that are empty. Weird. How do I fill them? With the formula, correct? What boxes are empty again? Time. So what am I going to do? Distance divided by speed. So I'm going to do 300, and this is 300 over x plus 30. And this one's going to be 200 over x. And we say same time, so what should we do? Last time we added the time, and it equaled the total time, correct? This time it says same time, so what do we have to do? Set them equal. So we go 300 over x plus 30 equals 200 over x. How do I make a common denominator? One's a monomial, one's a binomial. Can we make them be each other? No, so we have to multiply them by each other, correct? So you're going to multiply this one by x and this one by x plus 30, which is still a nice one. Still not going to make us have problems. So this one we're going to multiply by x, and this one by x plus 30. So we get 300x over x plus 30, 200x plus 6,000 over x plus 30. Before we drop off our denominators, we're going to say x can't equal 0, which makes sense, it's a speed, and x can't equal negative 30, which also makes sense, it's a speed. Correct? Like you can't go negative 30 speed. So then we can set our numerators equal. We get 300x equals 200x plus 6,000. Subtract 200. We get 100x equals 6,000 divided by 100. And x equals 60 kilometers per hour. But what does that represent? That's Susan's family speed. And then John's family speed. Yeah, it was very boring.
That's like
Very boring.
a huge truck.
Hey, my truck can get like one.
Okay, so these ones I will be checking.
Will explode.
Well, the RPM goes to 5,000. A little screechy.
Shaky. And then we'll.
I use when I turn it on.
Okay, so these are the two I will be checking with my eyeballs tomorrow. My eyeballs just check things way better than you handing them in, because lately people have not been handing stuff in. Eyeball checking tomorrow. Page 350. I'll draw myself on the board again, don't worry. I know you're worried about that. Number 16 and 17. If you're someone who's like, man, I need more practice with rationals, there's this crazy thing called the review at the end of the chapter. You could just do some of it. Okay?
So, you know what's bad when you're like actually like pressing like I'm like kind of leveraging myself and like